Now this is again a conversion. You have to convert aniline to benzyl amine. So you have to convert aniline to benzyl aniline. So what are the steps you will follow? So let us take half minute time. How many of you can do this one? Quite easy problem. So first you see the product, you have to increase one carbon. So here you have one CH2 and here I have only NH2 group. So it seems I have to increase one carbon. So reaction, we have to increase one carbon. That is important point. So now you see how will you proceed. Can you use diazonium cation reaction? You can use diazonium cation reaction. So first you treat with NNA2HCl, you make the diazonium cation, keep the temperature around 0 degree centigrade, and an intermediate gets isolated, and then you treat with CuCN, that is Sandmeyer reaction. If copper salt is used, this is called Sandmeyer reaction. And then what you can do? You have CN, then you can do reduction. Easy one. So let us see. You have NH2 and you first treat with NNA2HCl. This step is simple step. Now this will form diazonium cation. So I will have N2 plus Cl minus. Now in the next step you treat with CuCN. So you will have diazonium cation gets replaced by Cn. So you will have Cn, C triple bond N. Are you getting? And now next step, what you can do reduction of this compound. So you have this, and you can do reduction using H2PD. So if you do reduction with H2PD, what you will have? You will have one benzene ring. So this is H2PD. So you will have benzene ring that connects CH2 and H2. So this is the final product you will have. Let us discuss, because CH2, H2PD, what it will do? It will reduce these two double bonds. So one double bond CH NH, another double bond gets reduced, you will have CHNH. So you will have CH2 NH2. Let us discuss this problem. So this is again a quite easy problem. So question says we have C5H13N and this compound is optically active compound. Let us call this compound as X. Now if this compound is treated with NNA2HCl, and the question also says there is a loss of one N2 molecule. Do you remember we have said in the class aliphatic diazonium cations are not stable, but aromatic diazonium cations are stable. What is the reason? Aliphatic diazonium cation, no resonance. In aromatic diazonium cation, benzene, there is a resonance, and that's why aromatic diazonium cation gets isolated around 0 degree centigrade. But aliphatic diazonium cation cannot get isolated. So this must be, so there is a loss of nitrogen, that is the diazonium cation is not stable. This suggests this compound has to be aliphatic compound, and this again only 5 carbon, so it cannot go to aromatic. Now this gives Y, and Y is a 3 degree alcohol. Question says write down the steps for the following reaction. That is, you have to write down the mechanism, and in the last you have to tell me whether Y is optically active or it's not optically active. So let us take some time and see how many of you can do this one. So this is a quite easy problem. Mechanism based problem, already asked in JEE. So these questions we are discussing where they have already asked in JEE. So you see, you should have an amine, and that is optically active. That is the important point. You try to write something. and optically activeness, that will give you NFin. And finally you are getting a 3-degree alcohol. So let us say you have an amine CnH2, and now you should have how many carbon more? You should have 4 carbon more. So you will have 1 carbon, second carbon, and you can put 1 hydrogen. So this side you have CH3. If you put CH2, CH3, so you have how many carbon? 1, 2, 3, 4 carbon. So you need 1 more carbon. And finally you are getting a tertiary alcohol. That is also important. If you replace this nitrogen N2 plus and if you add 1 OH group, you will not get a tertiary alcohol. Are you getting? But so this is not a right option. So if you lose NH2 plus, put the OH group here, you will not have a tertiary alcohol. But if you put something like this, in this case you will have only 4 carbon. If you place 1 more carbon here, this carbon does not remain optically active. If you place this side 1 carbon, that is not optically active. So one situation is, I can place 1 carbon this side. So if I place 1 carbon here, that is CH3 group is here, and if I write this as a CH2 group, so again this will be not optically active. This will be not a tertiary alcohol. What I can do is, if I do something like this, so let us say 1, 2, 3 NH2 group, CH3 group. Now if I put 1 carbon here, are you getting? If I put 1 carbon here and then hydrogen here, this carbon is optically active. You see, this carbon is optically chiral carbon. Now I can get the tertiary alcohol. How this is so? Because now there is H, there is CH3 and there is CH3. If I lose N2 plus, I will get carbocation, and this carbocation gets rearranged. Then I can, in that case, I will get 1 here OH. Are you getting or not? So this must be X. That is a tertiary amine that is optically active. Now if I treat with NN2HCl, first I will get carbocation, CH, CH3, and the mechanism of getting carbocation I will not discuss here. We have already discussed in the class. So I am getting this carbocation. And now in the next step, I can do hydride shift. So if I shift a hydride from here to here, so I will have CH3, CCH3, and this side I will have CH2, CH3, and there is a plus carbocation, that is the rearrangement of carbocation. This reaction goes by even reaction, SN1 reaction, and that's why this is a carbocation has been formed. Next step, H2O can attack. So if H2O attacks on this carbocation, you will have, and if you lose H plus, you will have COH, CH3, and this side you will have CH2, CH3. So this is a 3-degree alcohol. Are you getting? And now this alcohol is not optically active because this carbon connects CH3 this side also CH3. So finally alcohol that is formed is not optically active. Not optically active. So this is not optically active. You see. So what are the important points we have? So you have to decide a alcohol that is optically active as well as give 3-degree alcohol, and that we have decided. If you take all the carbon in one line, that is in the no branching, normal chain, in that case you cannot get tertiary alcohol. But if you take one carbon branch with respect to the NH2, if you take branching here, that has no meaning. If you do branching here, and then this has also no have meaning, because that again will become a normal chain. So for branching I have only one option. I have to do branching here. And if I do branching here, I can get carbocation here, hydride shift, that will give you tertiary alcohol. That is the important point we have in this problem. Okay, let us discuss the next problem. This is a quite good problem.